So here was the work we just talked about with linear speed along an arc. Actually, I'm just going to clear this up real quick. So we're going to shift gears for a second. So linear speed along an arc of an object. Okay, we had two formulas, but they're basically the same thing. I'm going to write it like this, okay, if you don't mind, because this is, we're going to build off of this in a second. Now, there's also this idea of angular speed, where an object, okay, rotates through a certain central angle, right? So such and such object is here, rotates through an angle of, however many radians or degrees, okay, and the radius of the circle is something. This is a formula that we'll be able to use to calculate the speed of the object. But one thing that physicists look at, and mathematicians as well, is the rotational speed of the object. How fast is the object turning, right? How fast something is moving along the outside of that object, that's linear speed. How quickly something is rotating or turning, that's angular speed. Okay, and angular speed is again, it's the same idea as regular rate or distance, but instead of or regular rate or speed, but instead of talking about distance, we really only focus on how many rotations or radians something rotates over. So this is the angle of rotation divided by time. Okay. Now this could be given in terms of rotation. They could say a CD is spinning at 500 revolutions per minute. That's an angular speed, right? Revolutions per minute. Okay. Now revolutions, that can be converted into radians. And we're going to do plenty of examples of this. Okay. Just want everybody to understand the difference between linear speed and angular speed. And if you're wondering like why I drew the cursive W of like a 6-year-old, this is the lowercase Greek letter omega, which gets used for angular speed. Okay, so we'll reference this in certain problems. I just wanted to throw this out there. Okay, you're going to see radians per second, revolutions per minute. Okay, and anytime we talk angular speed, we're almost always going to be using radians instead of degrees. Okay, so here is again a second formula for finding angular speed. Okay, and if I may, I'm just going to do this real quick. This is what we have for linear speed. Sorry if you can hear my phone buzzing. Somebody's at my front door. This is what we have for the linear speed of an object. And you'll notice within this formula, we have this ratio, which is right here. So there is a third formula, if you will, for linear speed. It's still the linear speed formula, but we're replacing this with this omega. Okay, so if you know the angular speed and you know the radius of the circle, you can calculate the velocity or the speed of an object on the outside. So this is still linear speed of an arc length. Okay, linear speed along an arc. It's just written in terms of the rotational or angular speed and the radius, as opposed to having to calculate it all together like that, right? Let's look at a few examples.